In this section, we're going to talk about reflections, which is another type of transformation, and it's where a geometric figure is flipped over a line, some form of line. And the fancy term for that line is a line of reflection. Just think you're flipping a figure over a line. In a reflection, the pre-image, again, which is the original image, and an image have opposite orientations but the same size and shape. So again, essentially all you're doing is just taking a figure and you're flipping it over a line. So the size and shape is not changing, just the location. To graph a reflection image on a coordinate plane, you graph the images of each vertex. Each vertex in the image must be the same distance from the line of reflection, as a corresponding vertex in the pre-image. Essentially, when you flip an image over a line, it's going to be the same exact distance from that line as the original figure was. So it's kind of a way of checking your work. The rules for reflections are simple. It's going to be represented with a capital R. That's going to indicate to you that you're doing a reflection. And then down here, it will be what you are reflecting over. Sometimes you're reflecting over a line that you need to graph. Sometimes you're reflecting over an axis. And then it will tell you afterwards what shape you are reflecting over, or what shape you're reflecting, sorry. So that's what a rule for reflection would look like. Okay? So if we look at some examples, we want to reflect the following using the given rule. So we look at A. Sometimes it's written out in sentence form, reflect over the x-axis. Okay? Well, how I like to do reflections is it's telling you to reflect over the x-axis, so I'm going to highlight that. Here's my x-axis, that's what I'm reflecting over. And then all you have to do is count. That's all a reflection is. Okay? So I'm going to take each vertex and count how far it is away from the line I'm reflecting over. So this guy right here is 1, 2 away. So then I'm going to go 1, 2 in the other direction. Again, 1, 2 till I get to the axis that I'm reflecting over, and then I go 1, 2 in the opposite direction. You're going to do that same process with the other points, other vertices. So we're going to start with this one. This one's 1, 2. So I'm going to go 1, 2. This one up here is 1, 2, 3, 4, 5. So I'm going to go 1, 2, 3, 4, 5 in the other direction. Here, this one's 1, 2, 3, 4. So I'm going to go 1, 2, 3, 4 in the other direction. And there we go. Again, if there were points labeled, we'd have to put our primes, but there's no points to label, so we just don't have to label anything. Done. So really what we did, and I don't try to see the video, we took that first figure, and we literally just flipped it over that x-axis. So how the first figure was pointing up, we just flipped it over, so now that second figure is pointing down. And if you were to fold your paper in half along that x-axis for that graph, those pictures, those images should match up perfectly. That's one way of checking your work. If we look at B, this time we're reflecting over the y-axis. We have a capital R. Right here is telling me what I'm reflecting over. So it's saying I'm reflecting over the y-axis. So I'm going to highlight the y-axis. Then again, same steps as before. You're just counting how far each point away is from that line. We start with N. N is 1, 2, 3. So we're going to go 1, 2, 3 in the other direction. And label it N prime. N is 1, 2, 3, 4. So now 1, 2, 3, 4 in the other direction. Label that N prime. L is 1, 2, 3, 4, 5. So we're going to go 1, 2, 3, 4, 5 in the other direction. K is 1, 2, 3, 4. 1, 2, 3, 4 in the other direction. Label that K prime. And then just connect. So again, we took that original figure, flipped it over the y-axis. And again, if you fold your paper along that green line, those images should match up perfectly. And it doesn't matter which point you start with to reflect. You could have started with L and counted. Doesn't matter. Just pick a point, count, and then do the same thing with all the other points. With C, it says reflect over the line y equals 1. This is a little different. When you have an actual equation like y equals 1 that you're reflecting over, you're going to go to that number. So here's our y-axis, and I'm going to go to where y is 1, right here. And then you're going to draw a line through that value. You have to be super careful. We have to go across. It's really tempting to go up and down because that's the direction y's normally go, or up and down. But if we were to draw a line up and down, we're drawing a line through the y-axis, so it's touching every single y value. It's touching where y is 3, it's touching where y is -4. We only want a line that's touching y equals 1. So that's why we have to go kind of opposite of what we would normally go. Because here, it's only no matter what. Y is 1, y is 1, y is 1, y is 1. We're only graphing the line where y is 1. So be super careful with those. Those are tricky ones. Then all you're going to do is just count. So it doesn't matter which point you start from. I'm going to start from this one. I'm just going to count to see how far it is away from that line. 1, 2, 3. So I go 1, 2, 3 in the other direction. We'll go here. This says 1, 2. 1, 2 in the other direction. Go to the next one. 1, 2. 1, 2. This says 1, 2, 3, 4. 1, 2, 3, 4. And this guy's 1, 2, 3, 4. 1, 2, 3, 4. Finish your points. And again, you fold along that green line. They should match up perfectly. You need to pause. We're going to go ahead and move on to the next example. If you need to finish writing anything down, feel free to do so. With D again, we're doing your reflection because it's a capital R. This time we're reflecting over the line y equals x, which is an actual like slanted line. That's the very first line you probably graphed in algebra. So to graph this one, y equals x, you're always starting at the origin right in the middle. And then your slope is just 1 because there's not a number in front of the x. So you literally just go up 1, over 1. Up 1, over 1. Keep doing that across. You go, if you want up 1, right 1, you can go down 1, left 1. Down 1, left 1. Down 1, left 1. So whenever you're reflecting along y equals x, just slanted line right down. Start at the origin, just go up 1 over 1 till you're off the graph, and then go back to your origin and just go down 1, left 1 till you're off the graph. Okay. To reflect over this slanted line, all you're doing is counting, but you're counting a little differently because the line's slanted. Okay, I'm going to start with T. And I'm going to count down till I touch that purple line. So if we count, it's 1, 2, 3, 4, 5. So we touch that purple line. Okay. We want this image, because we're flipping it or reflecting it over that purple line, we want it on the other side. So to make this figure be on the other side of that purple line, we're going to go right 5. I'm going to label that T prime. If we went left 5, 1, 2, 3, 1, we're off the grid, but we would end up somewhere over here. And the original image and the final image are still on the same side of that purple line. So just kind of think, you're going to count down till you touch the line, and then think about which direction you have to move to get it on the other side. And in this instance, we have to go right 5 to get it on the other side. Okay. And you're going to do the same exact thing with all the other points. So I'm going to go to S. I'm going to count down till I touch that purple line. 1, 2, 3, 4, 5, 6, 7. Okay? And to get it on the other side of that line, I'm going to go right 7. 1, 2, 3, 4, 5, 6, 7. That's S time. Okay? Repeat that same process with U. I'm going to count down. 1, 2, 3, 4, 5, 6. I'm going to go right 6. 1, 2, 3, 4, 5, 6. Okay. Same thing with V. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And I know there's all those squiggle marks, but when you connect, it looks something like this. So if you were to fold on that purple line, that slanted purple line, those images should match up perfectly. It's a little different when it's slanted, but all you're doing is really just counting. If we take a look at E, again, we're doing a reflection because we have a capital R, and we're reflecting over the line x equals -1. So then we're going to go to where x is -1, which is right here. And we're going to draw a line through x is -1. Again, it's really tempting to go across. When you go across, you're going through the x-axis and you're touching every single x value. We only want to draw a line that's touching where x is -1. Don't go up and down. And then same exact steps as before. All you're doing is just counting. So C is 1 away from that line. So we're going to go 1 away. That's C prime. B is 1 away. Count 1. C prime. A is 1, 2, 3. Count 1, 2, 3. A prime. D is 1, 2, 3, 4. Count 1, 2, 3, 4. E prime. Do it again. Just connect those points. And if you were to fold over that green line, they will match up perfectly. And last one, again, it's a capital R, so we are doing a reflection, and we're reflecting over the y-axis. So go to the y-axis and highlight it. This one's a little different because the line we're reflecting over is going through that pre-image, the original figure. But the process is still the same. It's just when you graph it, it might be sitting on top of itself, and that's okay. So if we were to reflect S, S is 1 away. Well, when we count 1 away, it's sitting on top of R, and that's okay. Just make sure you label your point. That's why it's important. When we reflect R, and I'll reflect R in a different color, R is 1 away. So we go 1 away. It's sitting on top of S, and that's okay. You just have to make sure you label your point. Then when we reflect P, P is 1. 1 away, label it P prime. And then Q is 1, 2. 1, 2. Q prime. And then go ahead and connect R and S. P. So you can see it's the same image. It was just flipped over that line, and it's kind of all jumbled mess, kind of sitting on top of itself. That's okay, sometimes that happens. That's why it's super important for you to label your points. If you don't, then it just kind of looks like a jumbled mess. And you might not be able to tell what the correct picture is. So just make sure you label your points. Give me you need to watch the video again, go ahead. If not, get started on the graph.